So if you're trying to break into AI engineering, you've probably felt this, right? You spend all this time building up a portfolio of projects, but when you send them out, crickets. The standard chatbot tutorials just aren't making the impression you thought they would. In this explainer, we're going to break down the framework for building projects that actually show off real, professional-grade engineering skills.
And here's the thing, the problem is actually pretty simple. When you're just starting out, you don't really know what a production-level AI system looks like. So what do? You follow the online tutorials. And the result? You end up building the exact same ChatGPT wrapper or basic RAG app as literally every other candidate out there, making it almost impossible for you to stand out from the crowd.
So what's really the difference here? Let's break it down. On one side, you've got the typical tutorial project. It's basically a simple wrapper. You follow a guide step by step, and there's no real way to know if it's even any good. On the flip side, you have what we'll call the pro project. This isn't just a script, it's an entire end-to-end system. It's built with a clear design, and this is the crucial part, it has measurable metrics. This is what hiring managers are dying to see. Okay, so how do we fix this? The key is to start thinking like a pro and adopt what we're calling a professional engineering blueprint. Think of it as a framework, a new way of thinking that helps you move beyond those simple tutorials and proves you can build a real, robust, end-to-end AI system.
So what's in this blueprint? Well, it breaks down into about 8 core components. We're going to start with the most important part, problem framing and metrics. Then we'll walk through prompt engineering, selecting the right model, building a RAG system, creating agents, actually deploying the thing, and monitoring it. And then, as a little bonus, we'll talk about when fine-tuning actually makes sense. Let's jump in. First up, we have to lay a solid foundation. We're going to cover the first 3 pieces of the puzzle: proper planning, how to do prompting systematically, and how to intelligently pick your models. And honestly, these are the exact steps that almost everyone starting out just completely blows past. This right here is probably the biggest mindset shift you need to make. You have to start with a real problem, not just some cool new tool you saw on Twitter. In the real world, in industry, we first define the problem and then we figure out if an LLM is even the right solution. You've got to define what solved or good enough actually looks like for your specific use case.
So how do you measure good enough? Well, you need to think about metrics on a few different levels. First, you've got your user-facing metrics. These answer the big one: is this thing actually useful? Then you have technical metrics, which get at, is the AI itself performing well? And finally, system metrics, which are absolutely critical. They answer, is this thing sustainable? That means you're tracking stuff like latency and cost.
All right, next up, prompt engineering. The beginner approach? Just jamming a prompt into a file somewhere and calling it a day. The professional approach is totally different. You treat prompts like first-class citizens, like actual code. They're separate, they're version-controlled, and you systematically test and evaluate them against a real test set. So you've got your prompts dialed in, but which model are you going to send them to? It's so tempting to just default to the newest, biggest, shiniest model out there. But hold on a second. Is that massive, expensive model really the best tool for your job? Is it fast enough? Is it even worth the cost? You have no idea unless you actually test it.
In a real professional setting, we are constantly evaluating models based on a few key things. You've got to balance the cost versus the performance, you have to think about your latency requirements, and you need to see how good it is for your specific task. The big takeaway here is you've got to compare them head-to-head on your test set using the same rubric for all of them.
Okay, so we've got our foundation poured. Now it's time to build the engine room of this whole operation, the Retrieval Augmented Generation System, or RAG for short. This is really the core of so many modern AI apps. So what the heck is RAG? In the simplest terms, it's how you let an LLM talk to your own private data, like a company's internal documents. By doing this, the model can give answers that are way more accurate, they're up to date, and they're specific to your situation.
Now this is what I really love, because this is where you show your engineering chops. A real production RAG system isn't just about plugging in a database. You're making deliberate choices about your chunking strategy, which embedding model to use, your search and retrieval method. You might even add another step, like a re-ranker, to get that extra bit of precision. And of course, you have to measure it. How good is your retrieval? In other words, is it finding the right documents? Then, how good is the answer generation? Is the LLM using that information correctly? The magic here is that by testing each piece separately, you can pinpoint exactly where things are breaking down and go fix them.
Okay, so your system can answer questions. That's great. But what if you want it to actually do stuff, not just talk?
That's what we're talking about next. We're going to bring it all together and turn this code into a complete system with agents, deployment, and monitoring.
This is where AI agents come into play. An agent is basically an LLM-powered system that you give tools to. It's like giving your LLM hands and eyes to interact with the digital world. It can search the web, run some code, call an API, all to accomplish some bigger, more complex goal. Building one of these really shows you can handle sophisticated systems. But, and this is a big but, making an agent that isn't just a fragile toy is tough. You've got to think about serious error handling, because let's face it, LLMs mess up. You need to think about security, especially if your agent can execute code. And you absolutely have to have great monitoring and testing to make sure it's reliable. And this brings us to a really important point I want you to get. A project is just a script sitting on your laptop until real people can use it, and you have a way of knowing if it's actually working. That's why deployment and monitoring are such powerful signals that you know how to build a real end-to-end project.
Now, before we tie this all together, a quick word on fine-tuning. I know what you might be thinking. What about fine-tuning? Shouldn't I start there? Well, here's the pro tip. In the real world, it's often the last thing you do. A really well-engineered prompt and a solid RAG system will get you 90% of the way there. Fine-tuning is for that little extra performance boost, after you've already squeezed out all the other optimizations.
Okay, so let's put this all together. Let's follow a single request from start to finish in a pro-level system. It all kicks off when a user sends a query, maybe through a simple UI you built. That request doesn't just run a script. It hits a real API endpoint. And the very first thing that happens is the entire request gets logged. That's going to be crucial for monitoring later. Next, your system's brain takes over. If you've built an agent, it decides, okay, do I need a tool for this? If it needs info, it calls your RAG system. The RAG system does its thing, retrieves the best documents, re-ranks them, and then all that good stuff gets dynamically plugged into your version-controlled prompt, which then gets sent to the specific LLM you already chose through your systematic evaluation.
And finally, the model generates its response, and that gets sent back to the user. But here's the thing, in a real system, it never ends there. At the same time, all that valuable operational data, the latency, the cost, which chunks were retrieved, any errors, all of that gets shipped off to your monitoring system. And this is the secret sauce. This creates that feedback loop. The system gets smarter over time because you're actually watching it work.
Look, if you remember just one thing from all of this, let it be this. It is all about quality over quantity. A hiring manager would so much rather see one single, solid, well-engineered project that shows all these different pieces than 5 half-baked tutorials you just copied from a blog post.
So the next time you fire up your code editor, I want you to ask yourself this question. Are you building just another demo, or are you starting to build a real system? The choice is yours.